So my name is Don Fisi. I'm the CEO of S.G.T Tutorial Center. I'm once a student of the Premier University in Nigeria, University of Ibadan. So I want to introduce you to physics PHY 101, physics 101, which is mechanics. So we will start by solving the following questions. So after these questions, this is just introduction questions. So after these questions, I will be expecting you to give me in the comment section the area you need me to explain in physics 101. Any question you don't understand in physics 101, you drop it in comment section so that in the next class, in the next video under physics 101, everything will be treated well. Now see these two questions. You can see they are questions of the same group. We did this when we were in your 100 level doing physics practical. So whereby we are making a function to be in simple linear equation form so that we can plot the equation on straight line graph. Now see the first one here. Let's start with that first one. When you have PV raised to power A is equals to C, every one of you should know this from your secondary school that you take log of both sides. When you take log to both sides, the log of the same base to both sides, then we have log PV raised to power A is equals to log C. So what is the area of the common mistake where students can make? Students can take A here and have log PV is equals to log C, and this is very wrong. This is totally wrong because you can see that this A is a power of V, not power on both P and V. Therefore, the best thing to do here is to separate this function into log P. Let me write it here. So into log P plus log V raised to power A is equals to log C. Then from here, you say log P plus A log V is equals to log C. What's the next thing? If you take this to this side, you have log P is equals to minus A log V plus log C. Remember that the general equation of a straight line is of y is equals to mx plus c. So which means log P will be represented on the vertical axis, log V on the horizontal axis, y minus a represents what? Represents the slope, y log c represents the y-intercept. So this is just preamble of physics 101, and I'm very sure you must be familiar with this before. I just have to solve this for those of you that you don't understand this concept. Applying the same thing to the second equation. Okay, for the second one, x raised to power by is equals to z. So you will see that it is actually like the same thing with the first one. But here they specify that x, okay, this question is not complete, but they specify that x should be on vertical, while y should be on horizontal. So what will you do? When we take log to both sides, you have log x raised to power by is equals to log z. From here, we say log x raised to power b plus log y is equals to log z. Then b log x plus log y is equals to log z. Now from here, now the question is, we are making log x to be on vertical, log y to be on horizontal as specified in the question. So what will you do? It means you are making log y to this side, then you have b log x is equals to log minus log y plus log z. We divide through. by what? By b. Therefore, we have log s is equals to minus log y minus 1 over b log y plus 1 over b log z. Okay? Okay, this is another set of question under dimension. Dimension is another aspect of physics 101. Now here we are to determine the dimension of dimension of A, B, C, D, E. Now, in dimension, now we have been defining this y and z to be displacement. And being displacement, if you know, displacement is another representation of distance, length, which means the dimension of y and z, it is just L. In this sense, which means before you can add any variable, they must be of the same dimension, which means dimension of this is equal to dimension of this, and this is equal to dimension of this. For everything to be if you want to sum anything, add anything, the dimension must be equal to what we have here, which means this is equal to this in dimension, this one too is equal to this in dimension, while c is equal to this in dimension. I don't know if you get what I've just explained. Like now, going with this, we can infer that y, dimension of y is equals to at raised to power 3. Already, the dimension of y is also bt, dimension of y is also c. They must be equal in dimension. Since dimension of y is L, therefore we say L is equals to at raised to power 3. If you make A the subject of the formula here, then dimension of t is capital T. So A will now be equals to L per t cube. However, B, we say L is equals to bt, then B is equals to what? L per t. Which one again? While L is already C, then we say C is L. C is L. We've done this. We've done A. We've done A. Okay. Which one again? Now coming back here, Z. So for Z, dimension of Z is also L. L is equals to dt square. L is also E over T. So from here, we can infer that D is equals to L per T square. And from here, we can infer that E is equals to LT. So altogether, respectively, we say A, B, C, D are L per T cube, B, L per T, C, L, D, L per T square, while E, LT. Okay. All right, so let's look at this. Now, this is equation of wave y is equals to a sine omega t minus kx, where we already know that y is displacement, a is amplitude. This is angular velocity time constant, which is 1 over lambda and x. So from here, to know the dimension of y, already we know that y represents distance or displacement. Therefore, dimension of y is a. That's that. A represents amplitude. Amplitude is also length. Therefore, the dimension of amplitude is L. Now, the dimension of sine omega t minus. Now, you want to find dimension of all this. Determine it because dimension of this is L, this is L. Therefore, dimension of sine omega t minus kx is equals to y over a. Because their dimension is equal, therefore 1. And finally, we can say it is dimensionless. It is dimensionless. It has no dimension. It is dimensionless. All right. Now, then for the last one here, we have to find the dimension of omega t. Omega t, omega t. You know, omega represents angular velocity, which is 2 pi f t t. Now, and f is already 1 over t, so this implies that 2 pi 1 over t times t. When t cancel t, this is just 2 pi. 2 pi has no dimension. Therefore, we say the omega t is also dimensionless. So dimensionless. So these are just simple part of dimension. When you have a challenging dimension question, you drop it on the comment section. All right. Now see this vector question. A and B are 6 Newton and 36 degrees to the positive x-axis, 7 Newton along the negative x-axis. Find the magnitude of ADs. Before I go into this, let me just briefly explain vector analysis. So under vector analysis, we have what we call vector representation, vector addition, magnitude of vector, then vector multiplication. So we have more, but let me explain this before we continue. Now, vectors are represented in components. In components, we have a component vector, we have two component vector, and we have three component vector. For under the representation of vector, now if you have this a component, another component. Now in this three component vector, you must be seeing this as three-dimensional diagram. Assuming this is your y component, this is x component, and this is z component. Now here we say the y is perpendicular to x, y is perpendicular to y, then z is also perpendicular to x. Now the representation of this x component is say I, then for y j, for z k. Now if I have vector A represented as a AI, BJ, CK, and another vector B, A2I, B2J, C2K. Now, what are the basic questions you can be asked on this? Now, for now, we have done representation of vector in three components. If it is just a component, it can just be AI, it can be BJ, it can just be CK. It can be just a component. You should understand when I say a component. When we say two components, it can just be I and J, or I and K, J, K, I, K, like that. Now, before we go into the real vector, now what are the basic things you can be asked? The first thing is determine the magnitude of this vector. Magnitude of vector, you must all be familiar with this from your basic further mathematics and basic A-level mathematics. On this, to determine the magnitude of A, the magnitude of A will be represented as square root of ax squared plus b squared plus c squared. If it is magnitude of B, that will be what? A2 squared, B2 squared, C2 squared, and so on like that. What else after the magnitude? You can have to determine the angle made to the horizontal. Now when we say angle made to the horizontal, you see we have y components, we have x components, we have z components. Most of the time, we always find the vector, the angle of that vector to the x component. That's why many times, even if you have three component vector, you will see that determine the angle made to the horizontal, we are considering I and j, which is x and y. Because this vector now, this vector has its is a component to y and component to x. For any point of z, it will still be in the same z point. I don't think you are getting this dimension if you can feel this in three-dimensional form. For example, if you have magnitude A to be equals to 2I minus 2J, if you have to determine the angle, for example, you have to determine the magnitude, you just do the way I explained. There is a magnitude of A is equals to square root of 2 square plus 2 square, and that is square root of 8. Because of 8. If you have to determine the direction, now the direction, you represent x to be positive, x positive x, 2, y negative negative y, which means this is your addition. Then we have your angle there. So the angle to this horizontal now, it means you are considering this, then we say tan theta is equals to opposite 2 over adjacent 2, and say theta is equals to 45 degrees. If theta is 45 degrees, then you can now represent your cardinal point north, south, west, east. Then this is south 45-degree east. I hope you are getting this. Now, this is when you are determining the angle made to the horizontal by a vector. This is different from angle between two vectors. So if I ask you to determine the angle made to the horizontal here or to a component here, the only thing you do here is just you are considering your ij, neglect k for now. When you get to advanced vector analysis, you can be determining angle due to the respect to k, angle due to the respect to j and k, and like that. But for now, we'll be working basically on angle between I and j. Now, after you determine that angle, you determine the magnitude, what else? The next thing is you know how to multiply and how to add vector. Let me explain all this before we solve this question, so that when you have more sample of this question, you will understand how to do. So the next thing I should explain here is addition. So if you want to do vector addition, before we do vector addition, of course. Okay, now I have explained how to determine magnitude of a single vector. I have explained how to determine how to add vector. The next thing, before you can understand how to determine angle between two vector, you must understand the basic concept of multiplication, which is scalar. We have two types of multiplication in vector analysis. We have scalar multiplication and we have vector multiplication. This scalar multiplication is otherwise called dot multiplication, while vector is otherwise called cross multiplication. Now, the basic concept is A dot B is equals to AB, which is absolute value of AB cos theta, while A cross B is equals to absolute value of AB sin theta. AB sin theta. So how do we do this? Okay, don't put it so that you don't get confused. Now, AB cos theta, AB sin theta. Now, if you have vector A to be 3i plus 2j, vector B to be equals to 4i minus 3j. Okay, see this question now. If you have to determine the scalar multiplication of this vector. Now, scalar multiplication of this vector, so vector A dot vector B. Now, what will you do? Like normal expansion that you are taught in your secondary school, you are expanding this. Many people don't know the concept about this expansion, so let me explain. Although we are just introducing the course, we still have a lot to do, but let's do this. Now, expanding this to, we say 3i plus 2j times 4i minus 3j. Pause. Now, I believe you must understand how we expand this 3i times this. When you see it to open this, this and this and this like. Now, under scalar multiplication, already you know that I dot I, as I state here, is I cos theta. Now, they are coplanar. They are on the same plane. Being on the same plane, the angle between them is 0. So remember that cos 0 is equals to 1. Therefore, all this become what? 12 times 1, 12. Minus, now ij, they are perpendicular to each other, as I explained the other time. Which means I and j, the angle between them is 90. Remember that you are doing dot multiplication. So cos 90 is 0. Yes, cos 90 is 0. So if cos 90 is 0, then we say I dot j is 0 times anything is 0, 0. Then here j times I is also the same thing, 0. And j times j is 1. Why is it 1? Already I said it. The angle between them is 0. Sin 0 is what? Cos 0 is 1. Once cos 0 is 1, then we say minus 6. And finally we say 12 minus 6 is equal to 6. So that is the scalar multiplication. So what are those things we can learn from this scalar multiplication? You see that our final answer is in scalar form. It is not in vector form. I hope you understand this. Now, when we go to the vector multiplication of this A and B, so let's see the vector multiplication of that A and B. Okay, for the vector multiplication, A cross B. So let's start from this point. Let's start from this point. So in vector multiplication, you see that I cross I. Now, picking from that point, we have 12I cross I, 12I cross I minus 9I cross J plus 8J cross I minus 6J cross J. Now, there's something you must understand here. Under the IJK, now so this is IJK. Now, I times J, I cross J is equals to K. I cross J is equals to K. J cross J cross K is equals to I. And also K cross I is equals to J. Then if otherwise, if you have J cross I, that is minus K. If it is K cross J, that is minus I. And if it is I cross K, that is minus J. So once you're able to take note of this, then it is easier to understand the multiplication at that point. At this point now, so we say 12. So you have I cross I. I cross I, angle between them is 0. So what is sine 0? Sine 0 is 0. You can see here, this is cos 0. So sine 0 is 0, which means all this become 0. How about IJ? IJ is K. Then that become what? Minus 9K. Because angle between I and J is 90. And sine 90 is 1. Okay, how about this? J times I. J times I is minus K. Therefore, we have minus 8K. How about this? J times J. J times J is 0. The final answer we say minus 9K minus 8K. And finally, we say minus 17K. Now, from here, you will see that the final answer is actually in vector form. So this is cross multiplication, while this is dot multiplication. Now, applying this in determining angle between two vectors. Now, let's find the angle between these two vectors, A and vector B. Now, once you are doing this, we are using the concept of dot multiplication. And how we do that? When we say A dot B is equals to AB cos theta. Now, to know the angle between these two vectors, we now say cos theta is equals to A dot B over AB. Then we say theta is equals to R cos A dot B over AB. Now, I want you to follow me well. Now, cos A dot B, already we know our A dot B here, we have worked it to be 6. Then when we say AB, what is the meaning of AB? AB is you determine the magnitude of A times magnitude of B. Magnitude of A times what? Magnitude of B. So how will you determine magnitude of A in that instance? Magnitude of A can be best determined from A will now be square root of 3 square plus what? 2 square. And that is square root of 9 plus this, that is 13. However, B, magnitude of B is equals to square root of what? 4 square plus minus 3 square. B, absolute of B is what? Square root of 16 plus what? Plus 9. And that is square root of 25. And that is what? 5. Good. That is 5. Now, coming back here, we say theta is equals to R cos A dot B, that one is 6. A dot B is 6. R cos 6 over AB, that is root 13. root 13, root 13, that is 3.61 times 5. Then we say theta is equals to across 6 divided by 5 divided by 3.61. So that is equals 0.3324 using second shift course. And final answer we say theta is equals to 70.6 degrees. 70.6 degrees. Now, if you study this well, you will see this is how to determine angle between two vectors. The basic concept I want to explain here, I want you to be able to differentiate between angle made by a vector to the horizontal. That is when we use tan theta is equals to y over x. Then angle between two vectors, you come back to the scalar multiplication. A dot b is equals to ab cos theta. You find a dot b by multiplying this scalarly. Then AB, you find the magnitude of A, magnitude of B, then you then find the angle between the two vectors. Now let's now come to the solution to this question. Alright, so to do this, we have already know that A is equals to, now this is the force, this is the angle to the horizontal. We say 6 cos 36I plus, now why do I use plus 6 sine 36j? So why do I use plus for sine for the x and y? Now they say on the positive side of x, as we have something here, this is positive side of x, so you can see for y positive, for x positive, 36 degrees to the horizontal. So that is A, and from here you can say A is equals to 6 cos 36 is equals to 4.85I plus 6 sine 36, 3.53J. Then for B, they say 7 Newton along the negative x-axis. 7 Newton along the negative x-axis. 7 Newton. It is directly to the negative side of x. Say minus 7I. No J component. Because already the angle to the horizontal is 0, cos 0 is 1, sine 0 is 0. So if you use that concept, we still arrive at this point. Now, magnitude of A plus B, we say A plus B in magnitude, you are adding these two. If you add these two, it means you have 4.85I. If you add 7 minus 3.53, you arrive at minus 3.470. Okay, for the I component, okay, we are dealing with these two. 7 minus 2.15I plus 3.53J. So to now find the magnitude will now be square root of minus 2.15 square plus 3.53 square. Pause. Okay, now from here, from where I stop, you can see when you take the absolute value of this, you take square, you add it, then you have the square root, you arrive at that at 4.133 units. Now, second question, direction of AB. So how do we determine the direction? Remember what I explained. So the direction, you can use your analytical method. If you want to do the analytical method, you draw this. This is representing the negative x. This is negative x-axis, positive y, positive y. This is the direction of the A plus B. So this is 2.15 and here is what 3.5. So the angle here you want to determine, they say tan theta is equals to 3.53 over what? Over 2.15. So theta is equals to what? So from here, we determine the theta to be 58.66. So to represent the direction, you cannot stop here. The direction of A plus B can now be represented as, now if you check the cardinal point, this is north, south, west, east. Therefore, you can subtract this from 90. If you subtract this from 90, you have 31.34. Now we can now say north 31.34 degree west. Okay, Now let's go to this third one, magnitude of a minus b. So for a minus b, that is this vector a minus vector b, then you now find the magnitude as we did it here. So let me explain that. See, this is very simple. So this is just introduction to this 101. So in my next class, we are taking each topic one after the other. And any topic that you think you have a challenge under this physics 101. Also, we shall go to 102 and some other part of your science courses. Thank you for watching. Make sure you subscribe so that I can be alert for the next video. All right, thank you.